the final video in the series on Excel and VBA best practices as it relates to manipulating and accessing external data. Video is brought to you by PolarisInvesting.com, a site for creating defensible valuations. Recall, business valuation is based on expectations derived from skillful consideration of past facts and future possibilities. The series breaks videos up into front-facing Excel issues, another set of videos that focus on behind-the-scenes issues dealing with VBA. In this video, we're going to take a detailed look at the Polaris SP500 Analyzer App to demonstrate many of the concepts that we've been discussing over this series of videos. The video will spend a minimal amount of time discussing the purpose of the SP500 application and its navigation. For those interested in knowing more about those aspects of the program, I had to go out here to the PolarisInvesting.com site, go over to the YouTube channel, and you'll see there's a separate playlist on the use of the application. The thing I want to point out in this application, the convention is that any cell with a background color of gray is a cell where a user can provide input. So here on this SP500 worksheet, there's several places where user could provide input, and then on the industry worksheet there's several other areas as well. Now you notice at the top here that there's a security warning. External data connections have been disabled, and it's requesting that content be enabled. Well, this spreadsheet was just downloaded from the internet. In the security settings for this Excel environment, go over here to Options, Trust Center. We see here that when we look at external content, it's set up to prompt about content coming from the web, and that's why we're getting this message here indicating that the spreadsheet is open, but there's been no connections made, no VBA has been allowed to execute. Really nothing will go on with this spreadsheet until the user enables content. Well, let's go off and look at what's going on in the VBA code at this point. Go out and attempt to access the project. It is password protected, so it requires a password to be entered. Well, once the correct password is entered, you can see the different modules that make up the VBA project. And one of them is this workbook. When we go out and look at it, we can see here that when the workbook opens, there's really nothing that's done besides just putting the spreadsheet in a manual calculation mode. Even this is a little misleading, because when a workbook is in protected mode and it downloads a spreadsheet from the internet, this function, workbook open, is just not executed. Since this video was originally recorded, the call SystemCheck function has been added to the workbook open subroutine and will be executed if the spreadsheet is open from a local file. If the spreadsheet is opened immediately after downloading from the internet, the SystemCheck function needs to be called from other places. And in this spreadsheet, it's assumed that the user will enable content and click on one of the gray cells that's intended for user input. Now, when they click on one of those gray cells, let's take, for instance, here in the SP500 worksheet, you'll see throughout the code things called call SystemCheck. So it checks if that grayed cell is clicked on, and then has to make that check for all gray cells. So you see that call SystemCheck in various places. So the SystemCheck code contains code that would have normally been in the worksheet open event subroutine. Well, let's check out this SystemCheck function. First thing that it does is it puts the entire workbook in automatic calculation mode, essentially waking the spreadsheet up. Normally this is done in the workbook open event, but for reasons already discussed, that event does not occur when the spreadsheet is first downloaded from the internet. The next thing the function does is it places into the manage worksheet the current date and time that the spreadsheet was opened, and also the name of the spreadsheet. Next, it goes out and it checks certain cells to make sure the formulas that are expected to be there are actually there. And then it optionally, based on a flag in the manage worksheet, will flash up a reminder to the user on essentially a key aspect of the spreadsheet of how to use it. Next, it checks the Excel version that the user is using to make sure it's compatible with the application. Next step is it goes out to the internet, make sure there is a internet connection. If there is an internet connection, the public IP address of the system running this application is logged in the Manage tab. A call is made to determine the latest version, which goes out to a back-end SQL Server database that keeps track of the latest version available. And then that latest version is indicated on the Manage tab. Next, a check is made against the current version of the spreadsheet with the latest version, and it throws up a message if the current spreadsheet is out of date. Next, a check is made to see if what this app calls profile data is current, and if not, a message is flashed up. And then last, a check is made to see if there's any what's called a message board message available, and that's a call to the back-end SQL Server database, and if there is a message to be displayed to notify the users of something, then a pop-up appears with that message. Now, having gone through what the SystemCheck does, let's go quickly look at the Manage tab, and now we know that it's going to update the date and the time. There's also a flag over here set to on, so we know a pop-up is going to occur as well. So let's go back here and enable the spreadsheet. Now, enabling itself doesn't cause any VBA code to be executed. It just allows VBA code to be executed. Now, normally a user would hit one of these gray cells, so normally they go and check price data. And so you can see here that pop-up occurs during the system check. And then once it's done here, and then there's another check for the profile data, so another pop-up message occurs. And then once it's done here, retrieving current price data, we'll go check the Manage tab. And so here in the Manage tab, you can now see that the date has changed, that we're looking at now today's date and the current time. And here's the name of the spreadsheet. Now, to prevent that one pop-up from occurring over and over again, I'm going to go ahead and set this to off. Let's go back to the SP 500 worksheet. Now, let's assume that the user, noticing that pop-up about the profile data being out of date, refreshes that data. And the way that's done is the user would just click on this cell here, and you can see it goes off, and now it's accessing the internet and pulling back in and refreshing that data, and it gives a message when it's done refreshing. Well, let's go look and see in the code what it just did. So what we're looking at here is the SP 500 worksheets module, and specifically looking at the code that's in this subroutine for selection changes. And here it's checking the target address or the cell or range that just changed to see if it's that cell AJ1, which is set up to refresh the profile data. So that's a true condition. So now we're executing this code here. It checks to see if SystemCheck needs to be called, but because it was previously called when we right after enabling the spreadsheet, we updated prices. SystemCheck got called there. A flag was set that had already been done. And then it checks a flag on the Manage tab to determine the method to be used to go retrieve data from the internet. So it checks this cell D7, and if it's set to Power Query, uses the Power Query method to go pull data. If not, it uses the ADO function calls to go pull the data. So let's go check the Manage tab, cell D7, and you can see here it's set to ADO, but it could be also set to Power Query. Since pulling these four different data sets are similar, let's just follow one through, and we'll hear the SP 500 data query function call. Okay, here's the function that pulls SP 500 data. It should look familiar based on previous videos. Here at the beginning, it's declaring objects needed for the ADO API. Next, it sets up the connection string, namely here, going out to Azure database, and then passing in the account name and the password. And next is calling the SQL statement that it wants executed. Assuming this step is successfully executed, then the result set is placed into this array called row array. Clear off the landing area and then move the contents of the row array after transposing it using the Polaris transpose array function. We'll notice that the results are put into a worksheet named data. If we go out and look at the worksheets that's currently displayed, we don't see data. Now if we right click unhide, there we see data. So that's where the data is actually being placed. Before leaving this function, I want to show how errors are being handled. You notice up here we set on error, go to error handler. So after it executes this EDO call, if there is an error, it'll go to this label error handler and it'll set the function name equal to fail and then exit the sub. Compared to if it's successful, it'll set the function name equal to success and then returns either success or failure. Well, let's back up where we made the call into this EDO function called SP500 data query. And even though the current value in the manage tab is set up not to run Power Query, let's go ahead and look at the Power Query that could be selected. So to do that, we go up here into data and select queries and connections. The first thing I'm going to do is I'm going to right click on the SP500 data query and go to this load to and just show that it's going to load in a table in cell A1 of the data worksheet. A specific worksheet can be designated by preceding the cell with the worksheet name followed by exclamation point. So now by double clicking on the SP500 data query, it brings up the Power Query or the Get and Transform editor. You notice at the top here it displays the query that's being run, and it's running a select statement. Now if you recall, back in the ADO function, actually called a stored procedure to retrieve the data. The reason this is a select statement is that the Power Query is looked at in this application as a backup way to get to the data. So if for some reason the ADO function is not working, this uses just not only Power Query, but even a different way of pulling the data. I'll point out over here in the applied steps that outside of running the query, there are no additional applied steps. So pulling from a database that is assumed contain clean data, there's no need to be using a lot of the functionality of Power Query that's used to clean the data up. Well, that was behind the scenes look at what happens when in this application when a user selects this cell AJ1. Since this video was originally recorded, the scope of the video has expanded beyond just being an example of how to do data access. It now also serves as a code review of the application. So next we're going to take a look at the VBA code that gets executed when the user selects a watch list, also known as a portfolio, here in cell U19. This will result in the watch list area being updated. For more information on how to use watch lists, see the watch list or the save watch list videos in the SP500 Analyzer App playlist on the PolarisInvesting YouTube channel. When the user selects a watch list, or what's also known as a portfolio, from this drop-down menu in cell U19, you see here that the watch list area is updated. So let's go take a look at that code that gets executed. So here we are in the module for the SP500 worksheet, and we're looking under the change event code, and we scroll down looking for U19, which is right here. The target address is U19. Does a quick system check. We've been through that before. And then it turns off screen updating and even automatic calculation. Does a quick calculation to see where the last occupied row is currently in the watch list area, and then it cleans out the cells down through that last row. And then it repopulate the formulas that were in the rows. And you'll see later on that there's also a part here that will overwrite possibly those formulas. And therefore, every time you refresh with a new watch list, you must repopulate the formulas in all the cells. Now there was one problem here with formulas that go in column V in the watch list area, and uncertain why this is happening, but it had to be pulled out and done explicitly here in the VBA code to work properly. But all other cells in the different columns that make up the watch list are taken from a worksheet called active list and copied into here into the SP 500 worksheet. The reason those formulas are in another worksheet besides the SP 500 worksheet is there was no real convenient place to place those formulas that were guaranteed that they would still be there on every refresh of the watch list area. So it was decided that instead of explicitly writing the formulas in VBA code, it was more convenient to put them off into another worksheet, and that way it would be easier to update the formulas if need be. Now you notice the active list worksheet is not visible by default, so we go up here to take a quick look at it. I'm going to unhide it, make it visible. And while I'm at it, I'm also going to unhide the save list. Again, if you want to know more about this worksheet, I suggest you see the existing videos out there on that have already been cited to learn more about watch lists and save lists, but I'm going to unhide it as well. But let's go look at the active list, and here's the location of those different formulas that are used to populate the formulas here in these cells in the watch list area. The other part of this active list contains watch lists that the user just selected. So in one place there's a convenient place to go see what the data values are of the current watch list. Now, how that area gets populated is from the save list areas, all the different watch lists that can appear in the drop-down menu, and any values that the user decided that they want to have explicitly associated with a particular ticker in a watch list. So when it's populated, you'll see here that if there is an explicit value, there'll be a ... background to indicate that the cell formula has been overwritten with a specific value. And we can see that being done here in the code, that after everything's cleared off and the formula's repopulated, you then go through the active list and look for values that aren't blank and then place them in the watch list area as you loop through from row to row down through the watch list. Then when you're done with that, turns calculation back on, because need to go off and initiate a updating of the price information in order to bring both historic and current price data into the spreadsheet to be listed in the watch list area. Let's get back to discussing code that deals with data access. On the SP 500 worksheet, you select M1 to refresh price data. Since this video was originally recorded, you can now have M1 automatically selected on a recurring basis by activating a timer. The timer is controlled by these three cells in column L on the Manage worksheet. L1 turns the timer on and off. L2 allows you to associate a audible beep every time the timer goes on, and then L3 sets the duration of the timer in minutes. The timer can be quickly toggled on and off by clicking on cell 01 in the SP 500 worksheet. The code used to implement the timer is located in two different modules, Module 1 and Module 5, and then VBA code associated with the Manage worksheet in the SP 500 worksheet. Let's quickly review this code that's used to implement the timer. Starting off with the timer loop subroutine in Module 1. Ideally would have liked to enter in three parameters with this subroutine, namely the worksheet and the cell that want to select, or the action representing the action that's being taken, and then also a third parameter that would have been the duration of the timer. Was unable to get that to work, so chose to go with a simpler implementation that does not involve parameters. Before discussing the details of the timer loop, let's see how the timer loop is initially called. And that is done from the Manage worksheet when user changes cell L1 either on or off. If it's changed to on, then it first hides a couple of columns in the SP 500 worksheet, or if it's off, it then unhides those same columns. Then it calls the timer loop regardless of whether the user has just changed L1 to on or off. So now back here to the timer loop, it's important to understand that the timer loop itself is called every time the timer goes off. So either call it explicitly when a user changes the L1 cell on the Manage tab to on or off, or it's also called when the timer itself goes off. Since the timer loop subroutine sets up the timer loop subroutine to be called, it essentially forms a loop as timer's durations expire. So let's go back up here at the top, and when the timer loop is first called, it assumes that a timer just expired, even if it's being called for the first time. So think of this first call as indicating that a timer has just expired. So the timer gets turned off, and then it goes and checks to see whether the timer value in L1 is set to on. If it is, it'll then check to see if a beep is to be sounded, and it sounds a beep, because again, even if it's being called from down here, it assumes that indicates that the timer just went off, so optionally will sound a beep, and then it will do the action of selecting M1 since the timer has gone off. And then the next thing it does is it sets up for the next timer and looks at the L3 value for how many minutes to set the timer up for, and then it sets the timer and updates the application status to indicate that the timer has been turned on. And then when the timer goes off again, it comes into the same routine, and eventually when the timer is off, namely this value is set to off, it'll then come in and clear out the status bar. There are two other segments of VBA code that deal with this timer. Here is in the SP 500 worksheet VBA code, and it's for that quick auto price update, which goes and updates the value in the L1 cell on the Manage worksheet by just a click of the mouse on the O1 cell on the S&P 500. So it toggles back and forth and either sets that cell on the Manage worksheet to on or off each time the cell is clicked on the SP 500 worksheet. One other piece of VBA code dealing with the timer implementation down here at Module 5 in the SystemCheck subroutine. At the beginning of the subroutine now is it looks to see if the timer is off, and it just makes sure these potentially hidden columns in the SP 500 worksheet are unhidden. Now returning to the original video recording. So let's go follow behind the scenes of what goes on when cell M1 is selected. Looking at the selection change subroutine dealing with the S&P 500 worksheet, we already went through what happens if the target address is AJ1. A little bit further down is here if the target address is M1, and you can see here it looks to see if SystemCheck function needs to be called. At this point, if we were to click it again, it would not need to be called. And then at this step, it does a comparison with a value in the prices worksheet. The prices worksheet is not showing. If we go down here and do an unhide, the prices worksheet's not available to unhide. Back in the VBA code, if you click on the module prices, come down here, we see in the properties that it's got very hidden value for visibility. Now another phrase that maybe should have been used here is clandestine. If you just want to see it, click it to visible, and now it shows up. And what this line of code is doing is it's going out there and looking at tickers in a very specific area of the spreadsheet and comparing them to what's currently stored in a cell on the prices worksheet. This tickers function call is shown here, and it's basically just gathering up tickers into one string from the location that you specify. So you're passing exactly what worksheet you want to gather up the tickers from, what column number, what row you want to start at, and then the ending row. And you can optionally even pin other tickers on to whatever it finds in that particular column between those two rows. This allows you to call tickers within side tickers and just keep building up, pointing to different areas in your spreadsheet, worksheets, columns, rows, etc., resulting in an accumulated list of tickers. Returning back to where this tickers function was called from, you can see here that it's going out to column 21, starting at row 21, and it going down to row 550. Now it's not depending on any other tickers. It just says go create a list from that particular area on the SP 500 worksheet. So where it's at is over here in the watch list area, and creating a list out of the tickers it finds in this area. What we're doing is actually comparing a current list, which is what this returns, with what was there last time we made note of it. Let's go look at the formula in this cell N2 on the prices worksheet. And you'll notice here that it's calling tickers as well. In fact, it's calling tickers for the exact same area of the S&P 500 worksheet, namely that watch list area. But it's doing it also with referencing specific cell on the manage worksheet. And because it uses literal values, it will only update when this value on the manage worksheet changes. Let's go look at the manage worksheet. We'll see here in cell C9, pop-up comment here says cell cleared to indicate the watch list tickers changed on the S&P 500 worksheet. Right above that is another cell that says it's cleared to indicate that another area on the S&P 500 worksheet has changed. Back to the VBA code here is when a change is detected between what is current and what was last noted, the flag on the manage worksheet is then cleared, which causes essentially a new snapshot of the tickers on the SP 500 worklist area to be noted in that cell on the prices worksheet. The noting of values of the watch list ticker area did not have to be done in a cell. It could have been done in VBA, but this allows for a visual check on what tickers are considered to be in the watch list area. Now the cell to the right of where the tickers are listed is a formula multiple split historic, which we talked about in previous videos, and it references the ticker list in cell N2. So as soon as the tickers are updated in cell N2, historical prices are pulled for those tickers. Notice that the formula in N2 also makes reference to two other cells, namely cell in P1 and O1. Well, the cell in P1 is the historical date that you're asking for prices, and then O1 is the number of tickers in one group that the external data source allows. And that goes back to discussion in an earlier video where we were talking about when you go out to web services, often there's a limit to how much data you can pull back at one time. So this allows you to have a way of controlling how many tickers, how many prices you pull back each time you go out to the web service. Over here further to the right is another cell, Q2, and we look at the formula that's there, and it's calling the function multiple split, which gets current price data, not historical price data, but it's based on the same tickers in cell N2, and then it can be updated anytime the cell in Q1 changes or this flag on the Manage tab, cell C11 changes. Now Q1 is similar to O1. It controls the number of prices pulled back from a data source at one time. Both these functions, one for grabbing historical price data and another one for grabbing current price data, pull data from sources that return JSON data, and the functions convert that JSON data into CSV data to view the data more succinctly. Note the total number of tickers is limited by the maximum number of characters in a cell, which is 32,767, and the maximum viewable in a cell is 1,024. Then down here in the spreadsheet, we use the CSV split out functions to split out the individual records for both the historical and for the current price data. Reiterate again, everything that we just went through that takes place here on this prices worksheet could have been done all in VBA code. It was done this way so that there could be a visual check on the pulling of price data. And because the prices worksheet is very hidden, clandestine in the worksheet, it's really only intended for support staff to use to do troubleshooting. This area that's highlighted is referred to as a time frame, and this specific area is called the Watchlist time frame. This area here is referred to as the industry time frame. And then we also have the what's referred to as the SP500 time frame. But the three different time frames all behave in very similar ways. They're just pulling pricing data for different list of tickers. Returning back to the VBA code here, after it's cleared that flag on the Manage tab and then initiates all that price updating, it also does a check of another flag on that Manage worksheet to see if this message should be displayed to the user, and then it clears another flag that initiates the current price data to be pulled. Next, it goes off to the S&P 500 column 3 area to see if there's any new tickers in this column, which typically there's not after you initially open up the spreadsheet, but the user does have the ability to extend the list here, which is covered in the playlist on this application. There has been a change made, and a flag on the Manage tab is cleared to initiate that S&P 500 time frame on the prices worksheet to update prices. Also, it'll just simply clear a value to initiate current prices to be updated for the S&P 500 listed tickers. Lastly, the time and date of the last prices refresh are updated in the S&P 500 worksheet, namely here and here. Notice here in the VBA code there is no option to call a Power Query equivalent like we saw earlier in this video with the profile data. And the reason is that we had to do some pretty surgical work to identify exactly the parameters in the query, namely the tickers that we wanted price data for, whether we wanted historical price data, current price data. And Power Queries is more set up to bulk in a lot of data and then massage the data once you've retrieved it. Where in this case, we want to be pretty specific about what it is we're requesting before we go out and even pull it, and then by the time it comes in, there is a little massaging needs to be done because we've pulled specifically what we wanted. The last thing we want to cover here is what happens when the user closes the spreadsheet. When we go look at the workbook, and the event we're talking about is before close. Now, this function is called right before Excel completes all its shutdown processing. And what this function does, puts the spreadsheet in manual mode, so any of the changes made further down in this or subroutine are not visible to the user. So it ensures that no harmful VBA code is executed when the spreadsheet is eventually reopened. It then clears some things that the user could have done, particularly if the user had extended the list of the S&P 500 stocks in the S&P 500 worksheet. And if that did happen, it needs to just temporarily allow calculations so that the pricing information is in sync with the truncated list. And then it just goes about clearing out some other things, setting cursors on worksheets back to kind of home positions. It clears out any information about the user, namely their public IP address, and then the spreadsheet is completely shut down. Well, this video has been on a example of a lot of concepts that we've been talking about through this whole series of videos. Appreciate you watching the videos, and you have much success in pulling data in your future VBA projects.